Hello, and welcome to another openFrameworks audio programming tutorial. Today is a follow-up video on the previous delay tutorial. If you don't have the code, go ahead and grab it from the description. So right now we have a simple delay unit that will delay by 800 milliseconds and feed that back into itself. Test, 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 test. Seems to work. Okay, so the issue with our code is it's not portable, it's not really reusable, it's kind of fragile. So if we wanted to add, say, a multi-tap delay, it'd be kind of difficult and hard to read. If we wanted to use multiple inputs, we'd start naming them badly. Anyway, the point is object-oriented programming is really good at organizing your materials like this. So we're going to make two classes, one called tapIn, one called tapOut, just like exists in Max MSP. The reason I chose this paradigm is because I like the idea that if I make another tapOut, I can reference, see, the same tapIn as the other one without making another buffer and wasting memory. So I like the flexibility of this, and what we really want is to be able to make as many tapIns and tapOut as possible. So let's clean up our code. We can actually get rid of most of this and just start over. So if we go to our header, you can do this if you're following along the entire series. You can go ahead and add this to your audio tools. You could start another document if you want. I'm just going to write it above the of_app class just to keep these tutorials non-linear. So if somebody wants to start this tutorial, they can start and not have to follow along with the audio tools document. So let's make a class tapIn, class tapOut. All right, so we know tapIn needs some kind of storage. The way we did this before was a vector of floats. We'll call it buffer. I want to switch it now. Let's just call this a pointer to a float buffer, and we'll allocate that size in the constructor. So this just stores the address in the RAM of a floating point number. More on that later. See, we'll need a buffer. We'll need our write index. We'll need our size. And we'll need to store the sample rate. Let's make this public for now. That way we can access it in our tapOut. We can add a deconstructor and our constructor here. It's my understanding that if you don't add a deconstructor, it doesn't necessarily matter. I think it's already going to be there by default. But if you ever need it, it's good to have there. And I guess it's just good practice to make a deconstructor. I've never had to call them yet, in openFrameworks at least. So tapIn, and we'll need, let's see, what will we need? We'll need the buffer size. So in Max, when you make a tapIn, you just say how big is that tapIn going to be. So we'll need float. We'll do this in milliseconds. Time, milliseconds. We'll also need a sample rate, since we haven't stored that internally yet. All right. So let's make a static constant integer underscore size, and we'll set that equal to our time in milliseconds times 0.001 to convert to seconds times our sample rate. All right, and now we can set our buffer, which is a pointer to a float, equal to new float of this size. So 32-bit floats, and we'll have this many of them, and this will allocate enough space in RAM. This kind of thing, this is similar to writing, if we're using a vector, vector.resize in that integer number. All right, so we know that with the write index, it will start at 0. And the sample rate, we can go ahead and store that. Store size as well. So this will be an integer instead of a static constant integer. All right, so that's most of what we need. We also need a way to feed the tapIn, a way to give it new audio. So we'll make a function, call it feed. It will pass in the current sample. So float sample. All right, so our buffer at our write index equals sample. I'll call this current sample for consistency. All right, and then we can increment our write index. Write index equals write index plus 1. And then we need to loop if we get when we get to the end. So if write index greater than size, greater than or equal to size, write index equals 0. Great, that should just about take care of that. All right, so we have our tapOut class. So this one's gonna be a little strange. This is something we haven't done in this series yet, but we'll need, well, first of all, to make these public, we'll have a pointer to a float, and I'm gonna call this reference. And we want to reference the buffer of the associated tapIn. So we're going to have a mechanism to get the memory address and RAM of the tapIn's buffer. And this is how we'll store it. So we're just storing a pointer to the address of the tapIn's buffer. We do this because it would be really tedious to copy that address over. It would take a lot of CPU and time. So we just need the address of that. We'll also need size. We'll need a read point, and we'll store the sample rate here as well. All right, here's our D constructor and our constructor. All right, so we're going to need to get a lot of information from the associated tapIn. So I'm going to pass a reference into that entire object in rather than just the buffer. So if we make tapIn and then an asterisk, that means we're pointing to a tapIn, getting a reference to it. We're not actually copying it. And we'll call this nReference, or nref for short. And then we'll also, let's see, we need to decide how many milliseconds in the past this tapOut is looking. So let's do float time in milliseconds. All right, so our pointer to a float reference here is going to be reference equals our input reference. So this is our tapIns that we're handing it. And we need to point to the buffer of that tapIn. Now the address here is stored. So the address of whatever associated tapIn object is being stored here. Size equals nref size. And we have to use these arrows whenever we make something with an asterisk. That's the easiest rule. That's not in depth, but it'll be good enough for now. Sample rate nref and our read point, just like we did when we weren't using classes, will be our size minus time in milliseconds times 0.001 times our sample rate. So our time in milliseconds converted to seconds times the sample rate gives us how many samples how many samples in the past we'll have to go. Minus 1 because arrays start on 0. Okay, so our tapOut is constructed. We'll need a way to get a sample out of it. So we want to ask tapOut what sample it's on. So that should return a float. We'll call this get sample. Make a temporary float. So we'll ask our reference what's at our read point. So this is asking actually the tapIn what's at the read point. We'll need to increment our read point. And then wrap it around if it gets to the end, or when it gets to the end. So if read point greater than size, greater than or equal to size, read point equals 0. And then we'll return temp. Okay, so whenever we ask tapOut for the current sample, let's see if everything's right. Yeah, so we'll return the temporary reference, we'll increment that reference, and then we'll go back. Okay, so now we just need to use one of these. Let's go ahead and clean up from our last session. We don't need anything relating to the delays that were in the class. Okay. All right, so we need a new tapIn. tapIn. We'll call it tapIn. Let's call it my tapIn. My tapIn. And then tapOut. tapOut. My tapOut. Put an asterisk there. All right, so in our setup, we need my tapIn equals new tapIn, and we'll need to say how big it can be. So let's make it 10 seconds. 10, 1, 2, 3. So that's 10,000 milliseconds. And we'll pass in our sample rate, which is 48,000. And then my tapOut equals new tapOut. Which tapIn are we referencing? That'll be my tapIn. And how far in the past do we want to go? Let's go 800 milliseconds again. It should become happy eventually. All right, so current sample, we can set this equal to buffer at I. Let's get our current input sample. Let's feed that sample to our tapIn. So tapIn feed, we'll give it the current sample. All right, this will automatically progress and take care of itself. So what else can we do? Let's get the tapOut. Let's make a new variable called tapOut sample equals tapOut. Oh, whoops, this is wrong. This should be my tapIn, my tapOut, get sample. I'm going to move this up a bit. And let's listen just to the tapOut sample. So that should be an 800 millisecond delay with no recursion. It would be somewhat of a miracle if, after writing all those lines of code, that this works. Test? Okay. No surprises there, I guess. Ah, this should be input buffer. Too many buffers. Test, 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 test. All right, great. So we have our delay, and we're almost done. So just to conclude the way we did last time, we are getting our tap out here. But let's do some recursion. So let's add our output to our input. So we're feeding it our output now. So plus tap out sample times 0.7. Fix the order of operation here. Now we should have our recursion. Test, 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 test. All right, so that'll do it for today. It would be nice to have some kind of function to change the delay time. Right now it's only on startup. That'll be in the future tutorial. This is a static delay line, so it would, by definition, you can't change it without an error at the very least. So dynamic delay lines include objects such as a pitch shifter or just a delay line, and or you could do a flanger or something like that. So we will be using a dynamic delay line in the tutorial with the pitch shifter, which is coming soon. Thank you.